The bonding jumper from the island structure to the service entrance equipment should be number 2 copper. For NEC 250.66a, if a raceway or other wiring method includes conductors of different systems, the raceway or wiring method must be bonded at each end to the grounding electrode system. In this case, the raceway contains both line to neutral and neutral to ground conductors of the same system. Therefore, bonding is required at each end as per NEC 250.66a. NEC 250.66b outlines the minimum size requirements for bonding jumpers. For raceways 2 inches or larger, the minimum size is number 2 copper. Note 2 of NEC 250.66 states that the size of the bonding jumper for a grounding electrode conductor is based on the size of the largest grounding electrode conductor connected to the grounding electrode system. In this case, the bonding jumper from the island structure to the service entrance equipment is not a grounding electrode conductor. It is a bonding jumper for a raceway containing conductors of different systems. Therefore, Note 2 does not apply. The absence of bonding to the rebar is a separate issue that should be addressed. Rebar should be bonded to the grounding electrode system as per NEC 250.166. Let's delve deeper into the requirements for bonding and grounding at a car wash vacuum island, focusing on the application of the National Electrical Code, specifically NEC 250.66. Understanding these requirements is critical for ensuring electrical safety and code compliance. Firstly, it's essential to clarify the purpose of bonding and grounding. Grounding provides a path for fault current to return to the source, allowing overcurrent protective devices like circuit breakers or fuses to operate and clear the fault. Bonding, on the other hand, connects non-current carrying metal parts to create an electrically conductive path, ensuring that these parts are at the same electrical potential. This minimizes the risk of electric shock should a fault occur. Now consider the specific scenario of a car wash vacuum island located approximately 30 feet from the main service panel. The electrical supply is run through a 2-inch PVC conduit containing 4 120-volt single-phase number 10 copper circuits. The main service has bonding jumpers sized at number 2 copper, based on 250.66, with service entrance conductors of 250 kcmil copper. The question at hand is determining the appropriate size for the bonding jumper connecting the island structure to the service entrance equipment. The initial instinct might be to size the bonding jumper based on the size of the conductors supplying the island. However, in this case, the governing factor is the presence of a raceway, specifically the 2-inch PVC conduit containing multiple circuits. NEC 250.66 addresses this situation directly. It stipulates that if a raceway or other wiring method contains conductors of different systems, the raceway or wiring method must be bonded at each end to the grounding electrode system. In simpler terms, because the 2-inch PVC conduit houses multiple circuits serving different vacuum units, it qualifies as containing conductors of different systems. Therefore, bonding is required at both the service panel end and the vacuum island end of the conduit. Next, NEC 250.66b provides the minimum size requirements for these bonding jumpers. The key factor here is the size of the raceway. For raceways 2 inches or larger, the minimum size of the bonding jumper is number 2 copper. This requirement overrides any consideration of the individual conductor sizes within the conduit. Therefore, regardless of the fact that the individual circuits are number 10 copper, the bonding jumper from the island structure to the service entrance equipment must be number 2 copper. It's crucial to understand why this requirement exists. A larger raceway has the potential to carry a significant amount of fault current in the event of a ground fault. A number 2 copper bonding jumper provides a sufficiently low impedance path for this fault current, ensuring that the overcurrent protective devices at the service panel operate quickly and effectively. Now let's address the confusion surrounding Note 2 of NEC 250.66. This note pertains to the sizing of bonding jumpers for grounding electrode conductors. A grounding electrode conductor connects the service equipment to the grounding electrode system, such as a ground rod or a building's metal frame. The size of this conductor is based on the size of the largest service entrance conductor. However, In this scenario, the bonding jumper from the island structure to the service entrance equipment is not a grounding electrode conductor. It's a bonding jumper for a raceway containing conductors of different systems. Therefore, Note 2 does not apply. The size of the bonding jumper is determined solely by the size of the raceway, as specified in NEC 250.66b. It is important to differentiate between grounding electrode conductors and equipment bonding jumpers. The NEC provides separate sizing requirements for each, based on their specific functions. The absence of bonding to the rebar in the concrete slab is another critical issue that needs to be addressed. NEC 250.166 and other related sections mandate that rebar within a concrete foundation or slab be bonded to the grounding electrode system. This is because rebar, when encased in concrete, provides an excellent grounding electrode. Bonding the rebar helps to equalize the potential between the concrete slab and the surrounding earth, reducing the risk of touch potential and step potential hazards. This requirement applies even if the rebar was installed before the current electrical work was contracted. It's the responsibility of the electrical contractor to ensure that all applicable code requirements are met, including bonding the rebar to the grounding electrode system. The method of bonding the rebar typically involves connecting a grounding electrode conductor to the rebar using approved connectors. The size of this conductor is determined by NEC 250.66 based on the size of the service entrance conductors. In summary, the bonding jumper from the island structure to the service entrance equipment must be number 2 copper as dictated by NEC 250.66b for raceways 2 inches or larger. Note 2 of NEC 250.66 does not apply in this situation. The rebar in the concrete slab must also be bonded to the grounding electrode system in accordance with NEC 250.166 and related sections. Understanding and adhering to these requirements is essential for ensuring electrical safety and code compliance at the car wash vacuum island. Consider the following additional points to reinforce these concepts. Firstly, proper bonding and grounding are not just about meeting code requirements. They are about protecting people and equipment from electrical hazards. A properly grounded and bonded system provides a low impedance path for fault current, allowing overcurrent protective devices to quickly clear faults and prevent electric shock. Secondly, the NEC is a minimum standard. In some cases, it may be prudent to exceed the minimum requirements to enhance safety and reliability. For example, using a larger bonding jumper than required by code can further reduce impedance and improve fault current clearing. Thirdly, electrical work should always be performed by qualified and licensed electricians. These professionals have the training and experience necessary to ensure that electrical systems are installed and maintained in accordance with code requirements and industry best practices. They also have access to the proper tools and equipment to perform the work safely and effectively. Fourthly, regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical systems. These inspections should include a thorough examination of all bonding and grounding connections to ensure that they are tight, clean, and free from corrosion. Any damaged or deteriorated components should be replaced promptly. Fifthly, documentation is critical. Maintain accurate records of all electrical work, including as-built drawings, specifications, and test results. This documentation can be invaluable for troubleshooting problems, performing maintenance, and making future modifications to the electrical system. Moving beyond the specific scenario of the car wash vacuum island, let's discuss some general principles of bonding and grounding that are applicable to a wide range of electrical installations. The grounding electrode system is the foundation of any electrical grounding system. It provides a connection to the earth, which serves as a reference point for voltage. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, metal water pipes, or building steel. The grounding electrode conductor connects the service equipment to the grounding electrode system. The size of this conductor is determined by NEC 250.66 based on the size of the service entrance conductors. The equipment grounding conductor provides a path for fault current to return to the source from non-current carrying metal parts of equipment. This conductor is typically a wire or a metal raceway. The bonding jumper connects non-current carrying metal parts of equipment together, creating an electrically conductive path. This ensures that these parts are at the same electrical potential, minimizing the risk of electric shock. Ground fault circuit interrupters, or GFCIs, are an important safety device that can help to prevent electric shock. GFCIs monitor the current flowing in the hot and neutral conductors of a circuit. If there is a difference of more than a few milliamperes, the GFCI will trip, interrupting the circuit and preventing electric shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or AFCIs, are another important safety device that can help to prevent fires. AFCIs monitor the current flowing in a circuit for the characteristics of an arc fault. If an arc fault is detected, the AFCI will trip, interrupting the circuit and preventing a fire. AFCIs are required in many locations, such as bedrooms and living rooms. Surge protective devices, or SPDs, are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning, utility switching, or other events. SPD divert the surge current to ground, protecting the equipment from damage. SPD are available for a wide range of applications, from residential to commercial to industrial. Electrical safety is a critical concern in all types of installations. Proper bonding and grounding, along with the use of GFCIs, AFCIs, and SPD, can help to protect people and equipment from electrical hazards. It is important to follow all applicable code requirements and industry best practices when installing and maintaining electrical systems. Consulting with a qualified and licensed electrician is always a good idea. They can help you to ensure that your electrical system is safe, reliable, and code compliant. Electrical codes and standards are constantly evolving to reflect new technologies and best practices. Staying up to date in the latest requirements is essential for electrical professionals. Organizations such as the National Fire Protection Association, or NFPA, and the International Association of Electrical Inspectors, or IE, offer training and resources to help electrical professionals stay informed. Continuous learning and professional development are key to providing safe and reliable electrical services. Let's circle back to the specific situation at the car wash vacuum island to drive home the key takeaways. Remember, the 2-inch PVC conduit containing the four 120-volt circuits necessitates a number 2 copper bonding jumper from the island structure to the service entrance equipment. This is not based on the individual conductor sizes, but rather on the raceway size as per NEC 250.66b. Do not overlook the importance of bonding the rebar within the concrete slab to the grounding electrode system. This is a separate requirement under NEC 250.166 and contributes significantly to overall electrical safety. And lastly, always consult the latest edition of the NEC and seek guidance from a qualified electrical inspector or engineer if you have any questions or uncertainties regarding bonding and grounding requirements. Their expertise can help ensure compliance and safety in your specific application.